This is Dr. Bahauddin Abdullah and this is section 9.5. It is about determinants and Cramer's rule. So let us start by the determinant. If we have a 2 by 2 matrix like this, the determinant is denoted by two bars, two vertical bars like this, and it's defined as AD minus BC. So A times D minus B times C. For example, this is a matrix A. What is the determinant of A? It is 1 times 3 minus negative 2 times 2. So the result is 7. Now, how to use Cramer's rule to solve a 2 by 2 system, two equations and two variables using determinants or Cramer's rule. This is a system, two equations and two variables. Now let us call D the determinant of the coefficients A1, A2, coefficients of X, B1, B2, coefficients of Y. Let us call this determinant D. Now the determinant of X dx, you find it from D by replacing the coefficients of X by the constant terms C1 and C2. So dx is exactly like D, but you remove the column of X and you put C1 and C2. And that's the same you do to find the determinant of Y. You go to the Y column and replace B1, B2 by C1, C2. If you have these three determinants, then Cramer's rule says X would be dx over D and Y would be dy over D. Of course, D shouldn't be 0. If D is 0, we will see what happens. This is an example. Use Cramer's rule to solve this system. So let us form the determinant D. 5, 3, 4, 6. Find the determinant. 30 minus 12, 18. Okay. Now let us find the determinant X dx. Go to the column of X, 5, 3, and replace it by 12, 24. Now find the determinant. 12 times 6 minus 4 times 24, it is negative 24. Do the same to find dy. Okay, but replace the column of Y by the constant terms. Now multiply 5 times 24, 120 minus 36, that's 84. Now X would be dx, which is negative 24 over D, which is 18. So it's negative 4 over 3. Y would be dy, which is 84 over 18, which is 14 over 3. You can use your calculator, mode 5, equation 2, then you go to 1 in this case and solve the system and make sure the solution is negative 4 over 3 and 14 over 3. Now there is a definition, the definition of the minor. The minor of an element is the determinant that remains after deleting the row and column of that element. So for example, let us look to this determinant. What is this matrix? If you want to find the minor of 2, delete the row and the column and write 6031. The determinant of 6031 is the minor of 2. So that's the definition of the minor. Now this is the definition of the determinant of 3 by 3 matrix. If you have 3 by 3 matrix, this is the definition of the determinant. How? If you take the first column, you multiply A1 by the minor of A1. And you put a minus sign and multiply A2 by the minor of A2. How? Remove the row and the column of A2, you get B1, C1, B3, C3. Plus A3 times the minor of A3. Remove the row and the column, you get B1, C1, B2, C2. So this is the determinant of a 3 by 3 matrix. you can use any other column if you like, or any other row by doing the same. Multiply each element in the row or in the column by its minor, but take into account the sign of the position. These are the signs of the position. So if it's a 3 by 3, the sign is positive, negative, alternating. It is always like this. So here it is positive, negative, positive. This is an example. This is a matrix 3 by 3. Let us find the determinant of this matrix. Well, the determinant would be, I will use the first column. So it's 2 times its minor. Remove the row and the column, you get 6031. Change the sign of negative 5, multiplied by the minor of negative 5. If you remove the row and the column, you get 1731. Minus 4, multiplied by the minor of negative 4. If you remove the row and the column, you get 1760. Now find the determinant of this, multiply 2, you get at the end 80. So 80 is the determinant of this matrix. You can use your calculator also by going to mode 6 matrices, and you enter matrix A, and then you go to shift 4 and ask for the determinant of A, and it would be 80. Or if you want, you can use the last column, because there is 1 0 there. So it would be 7 times the minor of 7. So remove the row and the column. You get negative 5, 6, 4, 3. The sign of 0, the sign of 7 is positive. The sign of 0 is negative, of the position I mean. And the sign of this position is positive. It is 0, so I am not going to write 0, because 0 times anything is 0. Plus 1 times the minor, which is 2, 1, negative 5, 6. So it would be 80. It will give you the same answer. Cramer's rule, if you have system of 3 equations and 3 variables, is the same, but here each determinant would be 3 by 3. So D here would be the coefficients of x, the coefficients of y, the coefficients of z, and you find this determinant as here, and the answer would be 58. Now to find dx, you replace the coefficients of x by the constant terms, 16, negative 9, 2, and you find the determinant by the above method, and you get 116. So if the question used Cramer's rule to solve this for x only, so x would be dx over d, 116 over 2, which is 50 over 116 over 58, which is 2. Of course, you can find y also, it's dy over d, and z dz over d. Good luck.